Now let's talk about some of the differences between IPv4 and v6. Okay. So one side we will have IPv4.
Hello, sir.
Yes, please.
Sir, coming to organizations, every organization have only one kind of MAC address, or else they can maintain two or three.
That means?
Like you are saying, first 24 bits are from the organization code.
Correct.
Like they have only one, or else we can manage two or three. Like some of the organizations.
Like I said, that depends on the requirement of the organization. Okay. According to that, they will request the INA, and that according to that, INA will assign.
Okay.
Okay. So one side we will have IPv4 and other side will use IPv6. Okay. Now, what we'll do, first of all, I will give two examples here, and looking at those two examples of the IP address, we will see what are the differences. Okay. So let's say if we talk about your IPv4 example, let's say we have 192.168.10.1. This is IPv4 example. If we talk about IPv6 example, this is one example of IPv6 address. Okay. Now, just looking at these addresses, can you tell me some differences? One is size. Okay. So let's say you are saying IPv4 is 32-bit, and this is 128 bits. So in bits, B will be capital or small? Why not capital? It is? And what is a byte? Byte is 8 bits. Okay. And what is a nibble? Hmm? 9. Nibble is 2 bytes. Oh, 8 bytes. See, the smallest unit is what? Bit. Okay. Then after we have nibble. So 1 nibble equals to 4 bits. So that means 2 nibble equals to 1 byte. Then we have byte. That is 8 bits. Then we have kilobytes, which is
1024.
1024. 1024?
Which,
Sure.
yes,
Bytes. Bytes.
which bits?
It is bytes, bytes.
Oh, sorry.
Okay. Then megabyte. 24 kilobytes. Then one we have gigabytes. 1024 megabytes. Like this, it will keep on going. Okay. Now, let's say you take an internet connection and your service provider says we will provide you 100 Mbps or let's say 1 Gbps of speed. Correct. They will provide you 1 Gbps. And what you will think? You are able to download 1 GB data in 1 second. Is that true? No. Why not true? Why? Because when your service provider is promising you the speed, let's say you will pay for 1 Gbps. And I think all the service providers, they charge somewhere around 3,000 to 4,000 rupees per month. And you think that, okay, now my internet is so fast that I will be able to download 1 GB file in 1 second. Correct? But that is not true. Why? Because when your service provider, when they are promising you the speed, they are promising you 1 Gbps, not 1 Gbps. Sorry. Okay. They are not promising you 1 Gbps, but they are promising you this speed. That means gigabits per second, not gigabytes per second. And when you will use this speed, actual download speed that you will get will be equals to only 128 Mbps. This is what you're going to get. Why? Because byte equals to what? 8 bits. So they are promising you this. So eventually, if you will convert in bytes, that means you have to divide this speed by 8. And that is what you're going to get. So that means now you can understand that your 1 GB file will not get downloaded in 1 second, but it will take 8 to 10 seconds. Is that clear? Online people?
Yes.
Okay, so the bits, this bit is generally used for, we will say like speed. Whenever we are talking about speed, we generally talk about bits. And whenever we are talking about the data size, we talk about bytes. Okay, clear? Okay. Noted? And if you are paying for 100 Mbps, what you will get? 12.5 Mbps. That means they are just fooling us, right? Yes? Okay. Noted? Okay. So one of the difference, you said that, okay, it is size. Any other difference? See how we will find out the difference. So first difference we followed, that is 32-bit and 128-bit. Okay. Now this 32-bit, it is divided into how many parts? 1, 2, 3, and 4. My 32-bit is divided into how many parts? 4 parts. So that means each part will have how many bits? 8 bits. Okay. And the group of 8 is known as octet. A group of 8 is known as octet. So that means how many octets I have here? 4 octets. Okay. So here I have 4 octets. Clear? Okay. And here in case of IPv6, if I check, how many total bits I have? 128 divided into how many parts? 1, 2, 3, 4, 5, 6, 7, and 8. That means each and every part will include how many bits? Divide 128 by 8, 16. Okay, and a group of 16 will be known as hexstate. Okay, so that means how many hexstates we have? How come 16? How many hexstates? How many groups it has divided into? 8. And one group is known as a hexstate. So how many hexstates? 8 hexstates. Okay. So here we have 8 X8s. Okay. Then after you can mention, like your one octet will include how many bits? 8 bits. And one X8 will be 16 bits. Correct. This is clear. Okay. Any other difference? Ranges. Like what? Just looking at the address still you can tell more differences. What you see here, here you are using just numbers. Okay, from 0 to 9. And here you are using numbers as well as letters. Okay, so here basically we are using the decimal number system. Okay, and in case of V6, what we are using? Hexadecimal. Okay, then here you see the octets are separated by a dot. Okay, so you can see the dot is used for octet separation. Okay, and in the V6, what you are using for octet separation? Colon. Here. This is clear. Okay. Then you can talk about number of addresses. So if you want to calculate the number of addresses, what is the number of addresses in the IPv4? Very use. Approx 4.3 billion addresses. But we don't have to remember the exact number. In the interviews, we don't have to tell the exact number. How you can say? Whatever the number of bits, write in the power of 2, that many addresses. That means in case of V4, we have 2 power 32 addresses. And 2 power 1. This is how you can tell. No need to remember the exact number, because even if you remember V4, it is not possible to remember V6. Because in V6, we say possibly unlimited address. Okay, but that is not actually true. Still look. Okay. After all, it's just a number only. This is clear? Okay. So these are some of the differences, that you can tell just by looking at the addresses. Okay. And these 6 differences, if you tell in the interview, more than sufficient. Then there are other differences, like there is no IPsec support in the V4, but there is native IPsec support in the V6. Okay. But those things are related to once you study the security, like VPNs. Okay. So when you'll go to your CCNP, there you'll talk about VPNs, there you'll study about IPsec VPN also. Okay. So guys, why we have IPv6 concept? Because the number of IPv4 addresses are limited. Okay. Yeah, not really being used, you can say. See, it is being used like if you talk about your service provider Geo, entire network of Geo is IPv6 based. There is no IPv4 in the Geo. Yeah, already. Like I think IPv6 started during 90s only. Yeah. During 90s it was introduced. Okay, but the companies, they were not ready to shift really soon. Okay, so then they bought up some different concepts. Okay, like they bought up NAT, they bought up CIDR concept. Okay, and one addressing scheme was their IPv6. So these things gave us time, and still due to the NAT concept specifically, we are still able to use the IPv4 addresses. Okay. So this is clear. V4 and V6. Okay.